I'm going to be explaining how this compressor control circuit works. I got this wiring schematic from MotoLogic repair and diagnostic data, and this is the compressor control circuit for a 2005 Honda Civic, both 2-door and 4-door models, and it applies to manual transmissions and automatic transmissions. So to start this video off, I would like to state that I'm going to be using 3 colors in this video. I'm going to be using red to indicate parts of the circuit that are always powered regardless of whether the ignition is switched on or off. I'm going to be using orange to indicate parts of the circuit that are only powered when the ignition is on. And I'm going to be using yellow to indicate switch grounds. So let's start by looking at the power sources present in this circuit, and there are 2. One at fuse 1 and one at fuse 14. The one at fuse 1 says hot at all times. This is just another way of saying voltage is provided at all times to this part of the AC compressor clutch relay, which consists of the contacts. So I'm going to paint this part of the circuit red. So we can't really do much with this voltage because there's an open in the circuit. And in order for this voltage to ultimately power the AC compressor clutch, there needs to be a go signal of sorts. So with that, I would like to take you to this other power source here, the one at fuse 14. This one says hot and on, so this part of the circuit is only going to have power when the ignition is switched to the on position. So I'm going to color this part of the circuit orange. So it's important to note that just because you switch the ignition on doesn't mean that you're automatically gonna power the coil here within the relay and activate the magnetic field we need to close these contacts, because this part of the circuit needs to have a ground and that isn't provided just yet. So this begs the question, what is going to provide that ground? Well, the ECM/PCM is going to provide that ground, but certain conditions have to be met first, and we have to look at the right part of this circuit. Now, these conditions are actually pretty simple at a surface level. All you really have to do is turn the ignition on and turn on your AC request button. And what that's going to do is, once you press the AC on button, the heater control panel down here is going to ground that AC on input you send. When you press that AC on button, you're going to send an AC on input from the ECM PCM all the way down here. The heater control panel is going to ground that AC on input through the multiplex control unit and the AC pressure switch. So I'm going to paint this part of the circuit orange. So because the heater control panel acts as a ground once you turn on that AC signal, I'm going to paint this part of the circuit yellow to indicate the switch ground we get once we turn on the AC. So only when this occurs will these conditions be met that will ground this part of the AC clutch relay. So once this is done, the PCM is going to ground that power signal from fuse 14. So I'm going to paint that part yellow as well. Once this is done, this ground is ultimately established. Then with this magnetic field over here, close these contacts and power the AC compressor clutch. The relay contacts will now be closed, and the clutch then engages and will begin turning the AC compressor clutch. So once this is done, power is going to flow through fuse 1. That go signal will have been established, all by just simply pressing the AC on button. So I'm going to color this part of the circuit orange. And that's ultimately how the AC compressor clutch circuit works on a 2005 Honda Civic. I would like to point out two important things on this schematic. Now, one way to ultimately turn off the compressor clutch would simply be to press the off button on the AC, but there exist some safety measures, or rather protective measures, to prevent compressor damage. These are low pressure cutout switches and high pressure cutout switches. So ultimately, sometimes high side pressures can get too high. Sometimes high side pressures can get too high, and when that occurs, well, the AC high pressure cutout switch is gonna open the clutch circuit and disengage the clutch to prevent damage. And similarly, pressures can get too low, and if there's a low pressure switch equipped, which there is in this circuit, in this car, the same thing occurs. It will open the compressor, it will stop compressor operation to prevent damage. And the thermal protector plays a similar role as these pressure cutout switches, and it is mounted on the compressor to monitor compressor temperature. And if the compressor starts overheating or something for whatever reason, well, the thermal protector will similarly, like these cutoff switches, open the circuit and prevent compressor operation in order to protect the compressor. And well, that about sums up this video.